All right, good morning and happy Tuesday. It's October 31st, and I'm going to do the contest from last Saturday. So, unfortunately, I missed that, but I'll make up for it here. So, do it virtually, second best. Okay, grab this. That's cool. All right, I missed this guy. I'm pretty sure I missed this one as well. I might have missed this one too. Been slacking. All right, so we'll get to work here. I'll do biweekly contest 116 first. So here we go. Time to shine. Okay, so open these guys up. Oops. Okay, there we go. All right, separate distinct element sum squares one. Squares of distinct counts. One distinct value, one distinct value, one distinct value. Two distinct values. 1 to 100. Okay, well, we'll just do brute force since n is 100. Let's see, it's 10:14 a.m. Game plan. Since n is 100, brute force it. Right? It should be fine. N is the cardinality of the emperor A. And then we'll just say every ith starting value of length possible k. The sum of the squares of distinct counts. This square to that square, that square, that square, that square, okie dokie. Distinct values, all right. Here we are total return at the end here. Oops, return t for I in range n. So we start at each ith value and then for k in range 1 to n. If I plus k is less than n, so do actually this, n minus k. I think minus my I, right? I think that works. So I minus I, that goes that way, it goes that way. I think that works. Okay, so distinct counts. Oh, I see. Okay. Count goes counter a sub I until I plus k non-inclusive. Non-inclusive. I think that works. Okay. Plus k less than n. Yeah, okay. Yeah, that's fine. So the unique counts. So t plus equals the sum of values. Some music going here. What's going on? It's for it's in count of values, count. Say x, it's fine, right? X squared for each count of values in sets. Okay, I think something like that. That's what we're looking for. So it should be 15 and 3. Oh, 3 and 1. That doesn't look right. I'm sure. A sub I to I sub I plus k. Let's see what's going on. Okay, 10:17. We'll do some debugging. This is always costly, but I don't know what's going on. Count of a sub I to I plus k, non-inclusive. 0 to 1. 1. There's 2 1s. 0 to 2. Oh, because it's not inclusive, I see. Okay, yeah, so we do want 1 then, right? Plus 1. 10 and 6, that's not right. Holy cow. Okay, so it's 0 to 1. 0 to 2, non-inclusive. 0 to 3, non-inclusive. Looks right. It's not doing. Oh, I do want to not. Okay, start off at 0. Okay, so I had 2 logic errors in, right? Okay, still not right though. Dang. 0 to 0. Oh, there is no distinct value. Okay. Let's do this. 0 to 0 is 1. 0 to 1 is 1, 2. What is this? 1, 1. What is this? Oh, wait, hold on. It counts. Okay, 1 and 1. That looks good. Counts is 2 and 1. Okay, that looks right. So I'm just not squaring it right then, or so the squared for x in set of count dot values. Take equals this. Take. Here, let's just do this. Oops. Take. Let's put in the same line. Okay, and let's just do one example first. Saying 10, which does not look right to me. So what the heck, did I misread this? Take 1. Take 1. Take 5. 1. Squares of distinct counts. Distinct. Oh, the length. Oh, I see. Okay. Squared of the length of this guy. Okay. Take times take. Like, I don't know what the hell we want to call this thing. Squares of distinct squares. Distinct counts. I'll just call it take. 9 is not right. Oh. Okay, this is not going so good. Squares of distinct counts. Okie dokie. Right, here we took 1. That looks right. 0 to 0, we take 1. We have 1, according to the example. 1 distinct value is 1 distinct value. And we have 1 distinct value, which is 1 distinct value, which is 2 here. We have 1 distinct value, which is 1 distinct value there. Okay, then we have 1, 2. 1, 2 has 2 distinct values. 0, 1 has 2 distinct. Oh, dang it. Okay. It's the set of keys. Okay, it's not values, it's actually keys. Dang it. Okay. 15 looks right. Ugh. Okay, so sometimes fast is slow and slow is fast. Like if you're trying to rush, make a simple mistake like that, right? Okay, 15 and 3 looks good. Yes, okay, that looks good. It's accepted at 10:23. So it took like 9 minutes. 9 minutes for implementation in Python 3. Python 3, which is accepted. Yay. So a lot of that time, so it's like 3 minutes to write the code and then 6 minutes to debug it. So yeah, debugging that was a costly mistake. Just kind of misread it. Just call it X, whatever, it doesn't matter. Oops. Yeah, okay. It's a decent solution, right? It doesn't have to be perfect. That's good enough. So anyhow, that's the first question. Yeah, it took like 9 minutes. I'll post here a handful of solutions. These solutions. I just since n equals 100, you can root. Oops, of course. Consider all possible subarrays starting at each ith index. Of length. Okay. Plus one. To accumulate the total t. Wait, okay, that looks good. Whatever. Kotlin, JavaScript, oops, on 3, Rust, C++, oops, okie dokie. Python 3, there we go. Okay, using APIs, vectors, integers. Okay, then say t. T at the end here is our total. And then want to use a set and a map, right? Ordered set of integers using a map is an unordered map and as a counter. So for each ith value, it'll be it assigns integers, make that a little bit safer. There's this an in. Okay. Okay. So I don't know why I set this one to 0 actually. Let me go back to my Python code because I added one here. Might as well just do this, isn't it? Or is that the bug that I'm totally missing? I have to go to a +1 here, then 2, right? Am I way off? I don't know. This key. I'm sure it's taking a while. No, okay, that looks good, right? Instead of doing k+1, just do k from 1 to whatever the end, right? Yeah, that's a little bit better. Complexity is not intelligent, right? Simplicity is. So try to keep it as super simple as possible. Okay. Keep it super simple if you can. 0. So I want to describe this a little bit different. I think K. Okay, length K from 1 to I plus K is less than or equal to N, or less than N. So I to K plus K. And yeah, I think that looks right. So key non-inclusive, right? Okay, I to key non-inclusive. So let's see. Set. Or actually did to just do that count for auto. I want to do this. I want to iterate through I to K non-inclusive or auto it get up again plus I. It does not equal it up again plus K plus it. Increment the count of it. Just do this, just do it in there, it's fine. Okay, there's our map. It's initialized to the count of all the things between I to K. And then the X be the set of keys, size. Oh yeah, they can't just count their size, right? Actually, I can implement this a little bit smaller too. The it's the size of this guy, isn't it? I think the count. Yeah, that's easier, right? The count. Let's just do that. Instead of having an ephemeral value, it's way easier to see, right? Get rid of X. Okay, that looks good. A little more concise, a little simpler. I'll take it. And it's an iterative process. It's not like I compare immediately, but so it is. Okay, so T plus equals count the size multiplied by count size. Okay, something like that. Uh-oh. Oh, dang. Oops, it should be I plus K. Okay, that'll make a difference. That looks good. Okay, slight error, but that was rectified a lot faster than the other ones. So that's cool. Okay, so yeah, it's a decent solution. I don't know. This is kind of ugly, right? And yeah, C++ is verbose. The STL provides some values we can, or functions we can use, but count. Yeah, I don't think there's a constructor for an unordered map that I'd want to use. C++. Oops. So C++ CTOR for an unordered map. Take a look. It'd be nice if I could just pass in a container and count it, but I don't think there is an initializer list. Sure. Yeah, I want to use the map as a counter though, so it's not what I want. Okay, well, whatever. It is what it is. It's good enough. Let's do JavaScript and then move on here. 1033. All right, here's our array. And it TLBR total we return. Okay, and then I equals 0. I is less than input array A. I and 4 let k equals 1. I plus k is less than or equal to. So I'll use n. So I'll use them a couple times here. N. So I plus k is non-inclusive. Count be our map. Tree. See. I think I have a gist for this. Yeah. Let's use this. Use a string. I. That slice I to I plus k. T plus equals count dot size, multiply that count dot size. Looks good. All right, that's cool. 1035. So that's a little bit faster. That's cool. 2 minutes. Oops. For implementation in JavaScript, which is accepted. Yay. And that one's cool. So that just comes in handy because I don't really remember this. It's obscure, right? So using low dash count by, then feeding that into object.entries, and then creating a new map based on that. Right? So that took me a while to figure out. So yeah, I put a gist there so I don't have to memorize it, the info. Just go look it up, right? Why would I want that those data points to take up space in my mind, right? Might as well write it down. Okay, anyhow, let's do this in Kotlin. It's 1036. And I'll do the same thing. Got the gist for doing the counts. Y and 0 until n. For k and 0 until n minus I, inclusive. 1. So k is non-inclusive, right? Yeah, okay, for count, goodbye, just again here. This guy, string, grouping by it on each count. String a dot slice I to I plus k, non-inclusive. I might as well make it inclusive then, isn't it? N minus 1 minus I. 0 to that. So this guy, inclusive of k, join to string. Nothing is a delimiter, grouping by a dot each count. T plus equals count dot size multiplied by count dot size. Return T. E is our total return. Big money, no whammies. Looks good. Come on. It's taking a while. Uh-oh. Output expected. Oh, dang. That's not right. I wonder where it's off by. I to I plus K inclusive. Base size. To in non-inclusive. Okay. Inclusive. No, I don't know. Just do this. Maybe this is easier. Let's just do J and I plus one until N. J or just do this. Okay. Okay, I think this is easier, right? And then K is non-inclusive here. This is easier. Just say K. We'll just do I to J then in this case, right? J. Let's do inclusive then. J. Okay, I think that's easier to read, right? It doesn't matter, right? Let's move this down here. I'm pretty sure it's a slight logic error in how I'm calculating K, right? And it's not that simple. So might as well just use I to J, right? I think that calculation looks right. I to J inclusive. It's not right. Dang. That's nice to join the string, grouping it at each count. Count summaries. Huh. Oh yeah, that's strange. The heck? Seems like I'm doing the same thing. The counts off. Yeah, let's just do this. Let's try it the old-fashioned way. Counts the readable map of int int. All right, and then for KN I J inclusive count equals 1 plus count of a sub k, otherwise 0 if that thing is null. Count sub a sub k. for each kth value between I and j inclusive, increment the count, and then take the count size. Okay. Looks like it should work okay. So if that is right, which it is, then in that case, this function is not returning the count correctly. I don't care to debug that right now. Oh, I know why, because it's individual characters, so that's why. Okay. So yeah, this works for individual characters, but yeah, so I'd treat 2, 4 like 2, 4 instead of 24. Right. Yeah, so that's not right. Okay. So for single character values it works, but for multiple digits that does not. Okay. Good to know. Let's do this in Rust. And then, holy cow, it's taking like 30 minutes to do the first question. Yeah, a bit rusty, but whatever. So I in between 0 to n, not inclusive, and for j and 0 I until n not inclusive, for k and to j. Make it easier on myself, right? So for jth ending, construct the sum. And we are doing this over and over again, so pretty sure that'll lead us into Q2 here. Oops. Hash, the hash set for our counter. We have to location account sub entry borrowing a sub k, or insert if it doesn't exist 0. It's incremented by 1. T plus equals the count's length multiplied by the count's length as an I32. Okay, something like that. Uh-oh, entry count tree. Oh, it's not a hash set. I want a hash map. I want a hash map. Oops. I use a hash map as a counter. Oops. Okay, I do want that to be mutable. Okay, big money, no enemies, looks good. Okay, that's accepted. Cool. 10:47. Right, so about 3 minutes for implementation in Rust, which is accepted. Oops. Yay. Okay, so that's cool. Oops. Alrighty, a few solutions, right? So since n equals 100, it can brute force consider all possible subarrays starting at each ith index of length k to accumulate the total t. Yeah, that's good. Okay, cool. All right, Q1 is down, and we have 55 minutes left for Q2. Oh, okay, yeah, so it looks like this one would probably be the DP of this one, right? Because we're just basically doing the same thing over and over again, right? Yeah, I should go on to this one next. Right, okay, so this, the asymptotic bounds is set so that we have to have a DP solution. Okay, yeah, we'll just skip these ones, right? We'll just go to Q4 because that one seems interesting, right? And it's a direct follow-up. I don't know. We have 54 minutes. Let's see if we can do these ones real quick. If I can do them real quick, I'll do them. Okay. So otherwise, I really want to get to that Q4 because I have a hard time with Q4 for reals on the real contest. Okay, so it's beautiful. It's possible to partition to one more substrings. Even it's only 0 and 1s. Okay. Only zeros and only ones. Beautiful already. Each substring has an even length. It's either zeros or ones. They can just do a linear scan, isn't it? Even length. Right here, this is not an even length, this is a 1. So you change the 1 to 0, 0 to 1 doesn't matter. Same thing here. Okay, so let's just do a linear scan. Linear scan. And +1 for cost, right? Total cost, total T cost. They're basically greedy. Okay, it's 1050. So let's do this. I'll just say this is the array of characters. So for say so for I and range, say n is the cardinality of array A, 1 to n, non-inclusive. If a sub I minus 1, the one to the left, does not equal a sub I, right, we'll greedily say we have to +1 onto the cost and then move forward. No I is less than n. All right, we'll go up by 2s, right? Okay. Oh, I guess we can go up by 2s for I in range. Oops. 1 n by 2. And then we'll do the total. Well, I think we can do this as a one-liner actually, so this might be exciting here. T plus equals 1 for each of these things, right? I choose. Let's see what happens here. Should be 2, 1, and 0. 2, 1, 0. Okay, that's accepted. Cool. 10:52. So that only took 2 minutes. That's pretty awesome. 2 minutes for the implementation in Python 3. Oops. Python 3, which is accepted. Yay. Okay, next year, let's do this as a one-liner, right? Might as well. When changes is lambda itself, a, and we'll return the sum. I'm gonna just copy and paste this here like this so y'all can follow along. 1. Oh, I guess we can take just the length of this thing. Okay, I think that's what we want. Oh, n is not defined. That's right. Length of A. It's the cardinality of array A. It's in. Uh-oh. Generator length. Oh, I know. Get this thing here. 210 looks good. Okay, cool. So it's a one-liner. So basically the same exact thing that's here. It's accumulated in piecemeal fashion. We can just accumulate it here. So we can use the length, or we can just do the sum of all ones, I guess, 2, 1, and then just do sum instead of I. And that doesn't matter. Yeah, I kind of like this one more. Okay, that was fun. That's pretty cool. So let's post this solution as a bunch of one-liners. This is a pretty fun one. A few solutions. On 3. Oops. On 3. All right, Kotlin, JavaScript, Rust. Oops. C++. Okay. There's an array of characters, and basically we're just gonna say greedily accumulate the total T. I guess the total changes. Looking at each even index I from 0 until, or I guess each even and odd index from index pair, right? Pair. And I correspondingly from 0 to n minus 1 non-inclusive. Right, incrementing by 2. Okay, I mean, that sounds good, right? That's good enough. It doesn't have to be perfect. That's good enough. All right, let's do this. So I want to let's do this. C++ is easier just to do it iteratively. Plus equals 2. Yeah, I might as well just keep track of our total here. This, then T plus equals a sub I minus 1 does not equal a sub I, right? So if you don't meet that invariant, then you need to start at 1. Oh, come on. Got to pay the big bucks for that action. Okay, that looks good. Oops, okay, that's cool. Let's do this in JavaScript next. Okay, here's our array of characters. And then we're going to say, I'll just put in here too, right? Yeah. No, we're going to use it once, right? So low dash range from 1 to the cardinality input array A, non-inclusive, dot. I'm going to say for each of these things by, I wonder if low dash range by, I want to go up by 2's step. Okay, cool. Step is the third parameter. Okay, and then for each I, filter I such that a sub I minus 1 does not equal a sub I, and then return a length. Okay. Oops. What did I do? Okay. I think that's good. Okay, that's cool. We'll do Kotlin and then Rust. And we'll call it a day for Q2. All right. A is our array of characters. Did I describe this? Yeah. Really accumulate total changes required. Right. That is right. +1 for each different pair. Yeah, right. It is not equal a sub I, right? Like different pair values. Each set of different pair values. Okay, I think that makes sense, right? I don't want to kill it with too many details, but anyhow, let's see. Var this guy equals this guy. Turn you into a lambda to make it a little bit more concise. And then we'll say a dot. Okay, actually, we want to range. So 1 until size non-inclusive filter a sub it minus 1 is not equal to a sub it size. Oops, I need to go by two or step, right? It's step 2. Uh-oh. Size a dot. Oops. Strings have a length, which is not so helpful, I don't think. Okay. It's good. Boop. All right, and then we'll do this in Rust and move on to Q3. Rust, array of characters. Let A equals, we'll just keep this as S, whatever, S dot chars that collect as a vector of characters. That way I can use the index values for each ith index for comparison. Okay, so we'll return the range 1 till a dot length filter each ith value such that a sub I minus 1 is not equal a sub I. Collect it into vector I32s and then return the length as an I32. Something like that, right? Whoa. T size reference. What? Oh, I see. T size reference. That's fine. Just want to take the length of that thing. But the value type vector reference usize cannot be built from an iterator over elements of type usize. Type char cannot be indexed by a reference to usize. Reference to usize, what? Ranges of usize. Type char be indexed. Usize. What? Oh, I see. Okay. Right. We don't have to change ownership of this thing, which is fine. I think. So what the heck are you telling me? Slice indices are of type usize or ranges of usize. The trait slice index char is not implemented for usize reference. What the heck? Just tell me what the size of this thing is. The rest really gives me a hard time. So dang it. Oh, I need to go buy twos. Dang it. Rest step by two. Step by. Okay. Two. Okay, so this should be one instead of two. Come on. You gotta pay the big bucks for that action. Okay, that looks good. Come on. Yeah, all right. That works. I wonder if I need this part though, into iter. I'm just going through a range, right? Yeah, that's good. A little better without that part. I need to write it, better not. Less to look at. Okay, that's a decent solution, right? So greedily accumulate the total changes required by looking at each even and odd index pair. I guess each adjacent, I guess adjacent pair. It's better, right? Really filter. This accumulates the count of adjacent pairs, a sub I, and a sub I minus one and a sub I. Oops. From 0 to n minus 1, incrementing I by 2, right? And stepping by 2. different. Which says that a sub I minus 1 does not equal a sub I. Make this a little bit more concise, right? Something like that. Accumulate the count of different adjacent pairs a sub I minus 1, a sub I correspondingly, such that a sub I minus 1 is not equal a sub I from 0 to n minus 1 from, let's say, I equals 0 to n minus 1 inclusive stepping by 2 from I equals 0 to n minus 1 inclusive stepping by 2. Yeah, that sounds good. Okay, so there's Q2, and we have 33 minutes left for Q3. So if Q3 is quick, I'll do it. If it's not, I'd really like to do Q4 because that's the DP equivalent of that guy, I'm pretty sure. Okay, anyhow, let's do this. Longest increase, the longest subsequence. It doesn't necessarily be increasing. Just any long subsequence equals target 9. That's it. I think this will GLA if you consider all subsequences, isn't it? All possible subsequences is pretty big. Ooh, binary search. This is the binary search trick. Just guess. Right? Can we just guess? Can you sort it and guess? Since it's a subsequence, it doesn't matter, right? The sort doesn't matter and the order doesn't matter, right? You can pick and choose. Okay, so here's the game plan. Let's try this. Game plan. It's 11:11. I'd really like to have enough time for Q4. We're on Q3. We got 32 minutes left. And let's see, game plan is to sort A. Here's our input array A. There's our target. You know, it's sort, since order doesn't matter. Then we can cherry pick the longest subsequence. I guess the question is like, can we perform a logarithmic amount of guesses with the validation cost of a linear scan for each? And if so, right? If so, then we can use binary search, right? Otherwise, well, there's 1,000, so I think we could use a quadratic amount too. This one's tricky. Anyhow, yeah, I'm not sure exactly how to solve this one. So I really want to go to Q4. So I'm going to skip Q3, just go straight to Q4. Because, yeah, this one's DP of Q1, right? DP for Q1, basically all the overlapping subproblems with optimal substructure, right? So let's go back to Q1. Where's this guy? And I'll just grab my Python 3 solution. Oops. Okay, so I want to make DP out of this guy. Right, so we're basically going through the counts over and over again for each I and K. I wonder if we can do this top down with minimization. Or wait, hold on. I was thinking like prefix sums or counts, distinct counts. Okay, yeah. So how do I want to? We can see we're doing this part over and over again, right? So that's the majority of the work for each starting ith index for k, non-inclusive. I start here, go through all those. Start here, go through all those. Start here, go through all those. I guess, one quick optimization actually, even for this one, I'm pretty sure I can optimize this just to keep the count up here, right? Because we're only building upon the counter, right? Making it bigger. Count sub, a sub. Yeah, so for here, let's actually change this for j in range. Oops. I plus 1 to n, non-inclusive, then for k in. I to j, right? Oops. Yeah. Yeah. Want j to be inclusive then, right? Or should be inclusive. How did j inclusive? Count sub base of k. It's incremented by 1. These counts separate. Okay, this is what I want to do, I think, right? Yeah, pretty sure that looks right. Okay, that's cool. And I think this makes it easier, right? Kind of verbosely spelling out what I want to minimize. The DP, what's going on here? Can't hear anything. Some music going, okay. So yeah, here's our counter. Basically, we're going from I to J, counting it and incrementing the length. Count only gets bigger when there's a new unique element. Oh, when there's a new unique element, count times count. Yeah, so unfortunately, I don't think I can do this one really sharing my screen and talking out loud. It seems like something I have to write down on a piece of paper, right, to see the recurrence relation, right? So the key question is, right, right, what DP states can I use? And what are the recurrence relations between those DP states? So what work are we doing over and over again? Right, each time j goes up by 1, We're basically recalculating all the counts. Yeah, the funny thing about DPs is that it's difficult sometimes to find what DP states we can use and what recurrence relations there are between those states, right? Using the past to formulate the future in foresight, right? Conjured upon demand. But validating an existing DP solution in hindsight is actually pretty simple. And it's an interesting paradox. Yeah, so I don't know, offhand, just staring at this thing, kind of just thinking like, and see, okay, starting at I, we go for each j, and for each time j is incremented, we're doing all these counts over and over again. So that's one optimization, right? So just use the previous count there. That's fine. We can do that. But hold on, it's 100,000 though still. Right, so we could have a previous and current and use previous and it still accumulate on top of current, right? Here, actually, this one. I don't think this works, does it? We don't want the counter out here, do we? Huh. Maybe that is okay. Hold on. Have I confused myself? That looks good. Okay. Okay, yeah, so if we don't need to reset the counter here, then what am I doing? Okay, that's fine to have the counter way up here. So for each I, then we have the counter up there. Go through J, come at the count. Reach 5, reach I to J not inclusive. So when is the length of the count incremented then? Whenever we see a new unseen value, it seems like there should be a formula between distinct values and their positions. But yeah, I'm not sure exactly offhand. Uh, We've got 20 minutes left. I'm not gonna pour yell and stare at this thing. Target, so I should hop back on this one. So sorting this thing and then we got one. I wonder if we can do this one recursively then. Let's try. Got 20 minutes left. I'm trying recursively go. Pretty sure this will TLE though. There's our total T that we have. T equals T. How about so if not T, turn the longest subsequence. Say size. If and then we'll turn the size. Otherwise, if I move the length of A, and we got there negative infinity. If is less than equal to T minus A sub I, and include equals go I plus 1, size plus 1, T minus A sub I. Otherwise, negative infinity. Exclude is go I plus 1, size of T. Turn the maximum of include and exclude. Turn go. Okay, let's see what happens here. 34, negative 1. Uh-oh. Okay, so best is this guy. Return best if best is less than infinity. Otherwise, not equals 1. Okay, all right, 3, 4. Oh, best exceeds just is not equal to infinity. Max. This max. I think it's long and go. So this is negative infinity. We'll just do negative 1. All right, let's see what happens. Oops, I need to memorize it. It should TLE. With the memo, it might not TLE, right? Okay, let's see what happens with the memo. Seems feasible. Let's see what happens here. Big money, no whammies. Yeah, it might still TLE. Okay, yeah, TLE is on a slightly bigger input. Okay, so that is a correct solution, but how do you speed it up then, right? Including, excluding each ith item. Actually, I don't need to sort it here. But if I sort it or pre-process the input, maybe do like prefix sums or something, it might be able to help. Yeah, I mean, it works. It's a solution that works, but the input's too big. Yep, okay, I'm gonna call that a day, I think. Usually I get 2 or 3, so whatever. I'll land somewhere around here. 2. It sure is cool seeing this dude still jamming. He won that one. Oh wow, this guy's doing good too. Whoa, it took I see 35 minutes. What? That took 10 seconds after that. It's just weird. It took that dude 35 minutes to come up with that first question. Because it's maybe a weird question. Maybe, I don't know. Yeah, whatever. I can only speculate, I suppose. It would be cool though if more folks, I think, did post, screen share them jamming on this stuff. I think it'd be helpful. But what do I know, right? Okay, so yeah, let's see. How much time do I have left? Oops. 13 minutes. Yeah, so I'll upsolve them. I'll take a break and upsolve these. Right. So there has to be a more methodical way than just considering everything, right? So I got a brute force for, which is a good start. It's a good start to get the brute force. So I do see a subproblem with within the problem in that, yeah, I mean that's pretty much what it is, a knapsack, right? So the target goes down as you consume or include each item in your knapsack. I wonder if we can do DP reachability. Quadratic. Hmm. I wonder if we can do this. If we can use DP in a different way. Right, what if, let me just sort, but what if DP sub T is the maximum, like not subsequence, maximum length subsequence of total T. And then can we go from T equals 0 to T? And if so, how would we build this thing upon itself? It makes sense to sort it in that case, right? Nine. I wonder if we can look at an example closely. Maybe I can come up with this. I don't know. How much time do we have left? 10 minutes. Yeah, maybe. And it's 1, 2, 3, 4, 5, right? Three. So if we had some DP reachability, say, there's a Cardinalian parade. DP 0 multiplied by T plus 1, turn DP sub T might not exist. Get infinity. If dp sub T is not equal to negative infinity, otherwise negative 1. So for T in range 1 till T inclusive. All right, how do we, it's the longest way to reach this total? 1 plus the longest way to reach the previous total? We have to keep track of though how many values we looked at, right? Within the input array A. I think I see a quadratic solution similar to Dane's algorithm, best ending at each index. Again, yeah, this is kind of hard to see and type and screen share. I'm thinking I need to maybe switch it up and actually write some of this stuff down on a piece of paper because I'm pretty sure that would be more beneficial here than just kind of staring at my screen, kind of thinking in my head. It seems to make sense that we'd want to consider the smallest values first so we can include more of the smaller values to be accumulated to the target. Yeah, I don't know. I'm gonna take a break and then come back. 6 minutes left. This is pretty cool that LeetCode keeps track of like a real-time kind of progress. It is a little bit demotivational though to see it took some of these really good folks like an hour to solve this one. Holy cow. Or no, it didn't take them an hour to solve that one. It took not that long. This dude's pretty fast. It's awesome. And then an hour, holy cow. Conceptually tricky, I suppose. Q3 is kind of tricky too. I'm not sure. Sequence. Maybe recursive with the memo, but differently than an AppSec? Oh no. Ugh. I'm worn out. Okay. 5 minutes left. Yep. All right. I'll take a screenshot here in a few minutes. And I'll absolve the ones that I missed here. Maybe. Yeah, get back to him in a couple of years. Who knows? Let's see. Okie dokie. Let's see. Yay. Okay, I got 2 minutes and then I'm supposed to look at the I'm tired. The daily today. Let's see. Original array of prefix XOR. Interesting. It's gonna be kind of tricky. Yeah. Okay, so yeah, 1 minute. Capture a screenshot when there's only like 10 seconds left or so. Then I'll post this to YouTube. And if you all have any questions, definitely feel free to post comments on the LeetCode discussion post. So I'll try to post those links to those in the YouTube channel too. It might be easier to reach those. Alrighty. Okay, 47 seconds left here. Getting down to the end. Yeah, I'll land somewhere around here. Not my first rodeo where I've fallen off and gotten bucked off. All right, 25 seconds left. We'll refresh it maybe one more time here at 20, 15 here. It's strange that if we don't save this here, the LeetCode will actually kind of get rid of the progress, it seems, in that you can't go back and see this. So I'll end somewhere around here. All right, and that's all she wrote. Let's see. I'm gonna just give a screenshot here. Save to disk. Save this guy here. My contest 116. Okay, and catch y'all later.